May 15, 2024. Bakhmut direction. A Russian T-90M tank advances across open ground. $4 million of Russian engineering. 63 tons. Relight explosive reactive armor. Active protection systems. The crew believes they're safe. Armored. Protected. Advanced. 3 kilometers behind Ukrainian lines, an operator sits in a trench, wearing FPV goggles, controlling a quadcopter. The drone cost $400. Built in a Ukrainian workshop from commercial parts. Chinese motors. Ukrainian explosives. The operator sees through the drone's camera. First-person view, like a video game. Except the consequences are real. The drone accelerates 120 kilometers per hour, diving toward the tank. The Russian crew doesn't see it. Too small, too fast, too low. The drone strikes the turret top. Explosion. 1 kilogram of C4 equivalent. The tank's thin top armor fails. 20 millimeters cannot stop shaped charge. Penetration. Fire inside the crew compartment. Ammunition cooks off. Secondary explosion. The turret lifts, separates, falls. Catastrophic kill. 4 Russian tankers dead. $4 million destroyed by a $400 drone. And a Ukrainian operator who learned to fly FPV drones, racing them for fun before the war. This is WarFist TV, where we analyze the battles that change wars. Because FPV drones didn't just add a new weapon to the battlefield. They revolutionized infantry firepower and created a new era of warfare. Hit subscribe. You need to see how garage-built drones are destroying Russian armor at a ratio of 1 to 10,000. FPV stands for first-person view. The technology originated in drone racing. Hobbyists build small quadcopters, attach cameras, wear video goggles, fly at high speeds through obstacle courses. The sensation is like piloting an aircraft. Real-time video feed, responsive controls, adrenaline rush. Before the war, Ukraine had an active FPV racing community. Competitions, clubs, online forums. When Russia invaded, these hobbyists had an idea. FPV drones could deliver explosives. The concept was simple. Take racing drone, add explosive payload, fly into enemy target, detonate. Early attempts were crude. Commercial drones modified. DJI Mavic with grenades taped on, dropped from altitude. Accuracy was poor, maybe 10% hit rate, but the principle worked. Explosives from above. Enemy cannot hide in trenches, cannot use cover effectively. The tactic evolved. By 2023, dedicated FPV Kamikaze drones emerged. Purpose-built, not commercial platforms, custom frames, powerful motors, long-range video transmission, precise control. The specifications of modern Ukrainian FPV Kamikaze drones vary. Different manufacturers, different designs, but common characteristics. Frame, carbon fiber or aluminum. Lightweight, strong. Motors, brushless electric. 2,800 kV rating. High power. Propellers, 5 to 7 inches. Balance between speed and efficiency. Battery, lithium polymer. 4S or 6S configuration. Flight time, 10 to 15 minutes. Speed, 150 kilometers per hour. Maximum range, 5 to 10 kilometers depending on video transmission. Payload, 0.5 to 2 kilograms of explosives. Camera, analog FPV camera, 600/1200 TVL resolution. Wide-angle lens. Video transmitter, 1.3 GHz or 5.8 GHz. Power, 200 milliwatts to 2 watts. Range, up to 10 kilometers with directional antenna. Control, standard RC radio. 2.4 GHz typically. Total cost, $300–500 depending on components. Compare this to other weapons. Javelin missile, $175,000. Stugna P missile, $20,000. Artillery shell, $400–800. FPV drone, $300–500 with similar or better effectiveness against armor. The economics are revolutionary. Which FPV feature provides the greatest advantage? A. The production of FPV drones in Ukraine scaled rapidly. Early 2023, hundreds per month. Volunteers building in garages, small workshops. Components sourced from China, motors, electronic speed controllers, flight controllers, video systems. Purchased online, shipped to Ukraine, or smuggled when necessary. By mid-2023, thousands per month. Small factories established, assembly lines, quality control, government funding, Ministry of Digital Transformation, Army of Drones program, subsidizing production, purchasing drones, distributing to military units. Late 2023, tens of thousands per month. Multiple manufacturers. Standardized designs. Training programs for operators. Doctrine development. Integration into combined arms operations. Target for 2024, 1 million FPV drones annually. This goal appears achievable. Production is decentralized. Factories spread across Ukraine, Western Ukraine, Central Ukraine, even some near front lines. If one factory is destroyed, others continue. Resilient production. The training of FPV operators evolved. Initially, volunteers trained themselves, used flight simulators, liftoff, DRL simulator, practiced basic control, then progressed to real drones, empty fields, practice targets. Learning curve was steep. Flying FPV is not intuitive, requires hand-eye coordination, spatial awareness, muscle memory. But Ukrainian gamers adapted quickly. Many were already drone racers, others played flight simulators. The skills transferred. By late 2023, formal training programs existed. 2-week courses. Week 1, simulator training, basic flight, advanced maneuvers, emergency procedures. Week 2, real drone practice, culminating in live strike against training target, old Russian tank or armored. Enemies must hit target within 3 attempts. Pass rate, approximately 60%. Those who pass deploy to frontline units. Those who fail receive additional training or reassigned. Stay with me. The next section shows why 30% hit rate creates devastating attrition for Russian forces. The tactical employment of FPV drones is sophisticated. Each frontline brigade operates FPV teams, typically 5 to 10 operators, 15 to 30 drones on hand, resupply weekly. The team positions 3 to 5 kilometers behind front lines. Far enough for safety, close enough for drone range. They receive targeting information from multiple sources. Reconnaissance drones, traditional quadcopters like Mavic or Autel. Fly higher, longer endurance, spot targets, infantry observers. Ground forces identify enemy positions. Call for FPV strikes. Coordinates transmitted. Artillery spotters. When artillery cannot engage, FPV strikes instead. The operator selects target based on priority. Tanks highest priority. $3 to $5 million vehicles, high-value targets, infantry fighting vehicles, BMPs, BTRs. $1 to $2 million also valuable. Artillery pieces, self-propelled and towed. Destruction degrades Russian firepower. Logistics vehicles, trucks, fuel tankers, stopping supplies impacts operations. The strike procedure is standardized. Operator receives coordinates, launches drone, flies toward target area using GPS and visual landmarks, approaches from altitude, spots target visually through FPV camera, descends rapidly, maximum speed, target acquisition at 200-300 meters, terminal dive, aim point, top armor on vehicles, windows on buildings, trenches for infantry, impact, detonation, result assessed by reconnaissance drone or operator's last frame of video. Hit rate varies. Against stationary vehicles, 40-50%. Against moving vehicles, 25-35%. Against infantry in open, 30-40%. Against fortified positions, 20-30%. These rates seem low, but consider volume. One brigade operates 10 FPV teams. Each team flies 10 missions daily. 100 FPV strikes per day per brigade. 30 brigades across the front. 3,000 FPV strikes daily. 30% hit rate equals 900 successful strikes every day. The Russian casualties from FPV drones are substantial. Confirmed visual evidence for 2024. Over 2,000 armored vehicles destroyed. Tanks, BMPs, BTRs, self-propelled artillery. Actual number likely higher. Not all strikes are filmed, not all videos released. Infantry casualties are harder to quantify. Hundreds killed or wounded weekly. FPV drones hunt individual soldiers. Pursued across open ground, into trenches. Psychological terror. Russian soldiers report constant fear. Drones are always overhead. You cannot hide. You cannot rest. Any movement brings a drone. This fear degrades combat effectiveness. Soldiers hesitate to move. Stay in cover. Don't advance. Don't resupply positions. Don't evacuate wounded quickly. The operational impact compounds. If cost-effective lethality wins wars, type WarFist TV in the comments. Russian countermeasures evolved throughout 2024. First response, electronic warfare. Jamming systems, blocking RC control frequencies at 2.4 GHz. blocking video transmission at 5.8 GHz. Early jamming was effective. FPV drones lost control, crashed. Hit rates dropped to 10%. Ukrainian response, frequency hopping, switching frequencies rapidly. Jammers cannot block all frequencies simultaneously. Also, higher power transmitters, 2 watts instead of 200 milliwatts, harder to jam. The electronic warfare escalated. Russia deployed more sophisticated jammers, Pol 21, Muscovy AI-1, covering multiple frequency bands. Ukraine countered with fiber-optic FPV drones, physical cable connecting drone to operator, 5 to 10 kilometers of thin fiber-optic cable. Unreels as drone flies, cannot be jammed, no radio signals. Guidance is purely through cable. These drones are more expensive, $800, $1,000, but unjammable, effective against high-value targets. Second Russian countermeasure, cage armor, welded metal bars around vehicles, cope cages in Western media, barbecue grills in Ukrainian slang. The theory, FPV drone strikes the cage, detonates before reaching actual armor. Standoff distance reduces penetration. Reality, partially effective. Some drones detonate on cages, some penetrate through gaps. Shaped charges still damage vehicles even through cages. Operators adapt, aim for gaps, target exposed areas like engine grills, optics, hatches. The cages add weight, reduce visibility, hinder turret rotation, create new problems while partially solving the old one. Third countermeasure, increased air defense. More machine guns on vehicles, designated anti-drone gunners, armed with shotguns or light machine guns. Difficulty, hitting a small fast-moving drone is hard. Success rate is low, maybe 5 to 10%. Most drones reach targets. Fourth countermeasure, dispersion. Tanks operate alone, separated by hundreds of meters, makes mass FPV strikes less effective, but also reduces mutual support, makes tanks vulnerable to other threats. There is no perfect solution. Each countermeasure has costs. The FPV threat persists. The economic impact of FPV drones is staggering. Calculation, 1,000 successful FPV strikes per day. Average target value, $1.5 million. Mix of tanks, IFVs, artillery. Daily Russian losses, $1.5 billion in equipment. Over a month, $45 billion. Obviously not sustainable. Russia cannot lose $45 billion monthly. The actual sustained rate is lower, but even at 1/10 that rate, the attrition is severe. Compared to FPV costs, 3,000 drones launched daily, $400 each. $1.2 million daily Ukrainian expenditure, destroying $1.5 billion Russian equipment. Return on investment, 1:250 to 1. Answer, all three features synergize, but C, top attack capability is most decisive. Tanks have thick frontal armor, 900mm plus, thin top armor, 20-40mm. All tanks share this vulnerability. Weight constraints prevent thick top armor everywhere. FPV drones exploit physics, gravity-assisted terminal velocity, shaped charge penetration from above. This defeats even the most advanced armor. Low cost enables mass production. Precision guidance ensures hits, but top attack makes the hits lethal. The future of FPV warfare is clear. Production will increase. Ukraine targeting 2 million drones in 2025. Russia attempting to match production. Technologies will advance. Longer range, better jamming resistance, larger payloads, AI-assisted targeting, autonomous flight portions, swarm coordination, multiple drones striking simultaneously. Defenses will improve, better jamming, active protection systems, laser point defense, microwave weapons. But offense currently leads defense. Easier to build drones than to stop them. This imbalance will persist for years. Other nations are watching. FPV tactics will spread. Azerbaijan already uses them. Other conflicts will adopt. The technology is accessible. Commercial components, open source designs. Any motivated group can build FPV kamikaze drones. Should militaries worldwide adapt FPV tactics? Can defense ever catch offense? Will AI make human operators obsolete? Comment your predictions. Subscribe to WarFist TV. We analyze the weapons that define the future of warfare. The FPV revolution transformed the battlefield. Infantry gained precision strike capability. Direct fire against armor, without heavy weapons, without artillery support. A single soldier with a drone can destroy a tank. This democratizes firepower, changes tactics, changes force structure. Changes everything. $400. Carbon fiber frame, Chinese motors, Ukrainian explosives. 1 kilogram of violence delivered at 120 kilometers per hour by a 20-year-old who learned to fly racing drones online. This is modern warfare, not future. Present, happening every day. 3,000 strikes daily, 900 successful hits, hundreds of Russian vehicles destroyed weekly, thousands of soldiers killed or wounded by drones built in garages and workshops, operated by gamers and hobbyists turned soldiers. The revolution is complete. The question now is not whether FPV drones change warfare. They already have. The question is, what comes next? What happens when both sides deploy millions of drones? What happens when AI removes the human operator? What happens when the skies are filled with autonomous hunter-killers? We're about to find out. Stay vigilant.